Hello everyone. We are the heavy metal family. I am copper.
I am mercury.
I am chromium.
I am lead. I am silver.
We are the dangerous elements lurking in food and drug. In daily life, people turn pale at the mention of me, even though you can digest us using a microwave digestion instrument. We also have the element standard curve series solution as a helpful tool, but you can't observe my existence with your naked eyes either.
Don't get too cocky. I am here to see my fiery eyes.
How could this happen? How did we get exposed? And who is responsible?
We are the little assistant for the inspectors. With us here, don't think you can hide anymore. No matter how much heavy metal is hidden in traditional Chinese medicinal material, I can use.
Hello everyone. Do you know who the little helper mentioned above is? That's right. It's the atomic absorption spectrometer used for heavy metal detection. According to the Pharmacopoeia of the People's Republic of China, heavy metal content in medicinal materials should be determined using atomic absorption spectroscopy. Atomic absorption spectroscopy (AI) is an analytical method for determining the content of elements based on the absorption of characteristic electromagnetic radiation by the outer electrons of ground-state atoms. In today's session, we will demonstrate the use of this instrument through the specific application of detecting copper content in Panax notoginseng. The key and difficult point of this method is the use of atomic absorption spectrometer. Today, we'll take the detection of copper in sen, keep an notoginseng as an example to learn the use of atomic absorption spectrometer. Purpose of this experiment. First, master the structural composition and operation methods of atomic absorption spectrometer. Second, learn to use the standard curve method for quantitative analysis of samples. What does an atomic absorption spectrometer consist of? The instrument mainly consists of a light or spark hollow cathode lamp, an atomizer, a monochromator, and a detection system. The model of atomic absorption spectrometer used in this experiment is Beijing P or SEEAS 990, and the instrument uses flame detector. How do we use such a high-tech device for measurement? I. Preparation of samples and standards. First, prepare the sample and standard solution, the Panax notoginseng test solution after microwave digestion, and the standard series solution of copper. Second, instrument operation. The steps of this operation include: first, start up an instrument initialization. 2. Instrument adjustment. 3rd, measurement parameter setting. 4. Sample setup. 5th, sample determination. 6. Shutdown operation. First, start up an instrument initialization. First, turn on the air compressor and adjust the outlet pressure to 0.2 MPa. Turn on the acetylene and adjust the outlet pressure to 0.5 MPa. Second, turn on the device host in the computer. Click the AI1 icon on the computer desktop and click Connect to initialize the instrument. If the self-check items are all normal, the instrument will automatically enter the interface for selecting the working lamp and preheating lamp. Third, select the CU work light and preheat light, and follow the prompts for the next step. Fourth, the measurement parameters for the element are usually set to the default values. Click Next. Fifth, click the Peak Search button, and the instrument will automatically search for the specified measurement wavelength approx. 2 to 3 minutes. Sixth, after the peak search is complete, close the peak search window, click Next and then close. The instrument will display the main interface. Second, instrument adjustment. Click Burner Parameters under Instruments to select the appropriate combustion, gas flow rate and height. Repeatedly adjust the burner position, -5 to +5, so that the element light beam passes directly above the burner gap. Click OK to exit. 3. Measurement Parameter Setting. Click the Parameters button on the toolbar. Set the measurement times to 3, the measurement mode to automatic, the calculation mode to continuous, the integration time to 0.1 to 1 second, and the filter coefficient to 0.3. 4. Sample setting. First, click Sample and follow the prompts. The calibration method is usually standard curve, and the curve equation is linear. Select the concentration unit and click Next. Second, enter the corresponding concentration of the standard sample and click Next. Third, for flame method, select None and click Next. Fourth, click Finish to exit. Fifth, preheat the instrument for 20 to 30 minutes. 5. Sample determination. First, click the ignition button on the toolbar. After the flame has preheated for 10 minutes, start the measurement. Second, check if the energy value in the status bar is around 100%. If not, click Energy and then Automatic Energy Balance. Third, click the Measure button on the toolbar to bring up the measurement dialog box. Fourth, inhale the standard blank solution and wait for the data to stabilize. Click Zero Calibration and then start to read the data. Fifth, inhale the CU standard solutions from low to high concentration and click Start to read the data after the data stabilizes. 6. Inhale the sample blank solution and wait for the data to stabilize. Click Zero Calibration. 7th. Inhale the Panax notoginseng test solution in turn and click the Start button to read after the data is stable. 8th. After the measurement is completed, suck and spray ionized water for 5 minutes. 9th. After the measurement is completed, click Save or Print and follow the prompts to save the measurement data or print the corresponding data on curves. 6. Shutdown operation. First, shut down. Exit the AI when operating system, then turn off the host power supply, the computer, and the monitor in sequence. Second, turn off the acetylene and air compressors in sequence. Notes. First, the acetylene main meter shall not be less than 0.5 MPa. The gas outlet pressure shall not exceed 0.1 MPa, and the auxiliary gas shall not exceed 0.4 MPa. Second, each time you turn on the machine, check whether the gas and waste liquid pipes are leaking gas or water, whether the waste liquid can is full of water, and whether the end of the waste liquid pipe is inserted below the liquid surface. Everyone, that's the end of this experiment. Here's a question for you all. Heavy metals in medicinal materials are not limited to copper. How should other heavy metals be detected? Please check the detection standards on the Pugong Ying WeChat public account after class and answer the teacher in the Zoo Eggs Atong discussion area. After this session, we have gained a deep understanding of the technical knowledge of determining heavy metals by IS, which is an essential skill in the field of pharmacy. However, the purpose of learning skills is not only to satisfy personal curiosity, but also to better fulfill our social responsibilities. As pharmacy students, we always care about human health and bear the sacred mission of protecting human health. In the quality controlance of traditional Chinese medicine, we need to use our professional advantages, rigorous attitudes, and scientific methods to make greater contributions to human health.